All right. Back for the second half of today. Continuing on my other headset side, so I have to have these big ones on. But let's see here. I'm going to do this. All right. So hopefully this headset's working. Actually, let me see if I can test here. Test here. And it seems like I can, so hopefully that works. All right. So earlier today, in the first half of the day, um, we left off right here. If you weren't watching earlier today, we went through some things here, went through some random numbers, text, and we did some additional practice. We learned about random numbers and the import random and using random dot rand int. And we also did random. We also learned random.rand range, like that. And basically, the rand int was inclusive and was inclusive. So that means that if I were to say I want a random number or random integer from between or from 1 to 10, that means that this will generate a random number and it will include both the 1 and the 10 in that random generation. But with rand range, if I were to do 1, 10, I would get numbers from 1 through 9 because with rand range, 10 is exclusive, meaning it won't be included in that random number generation using rand range. So that's what we learned before. Go ahead and check out the other video. And I know my last video, I apologize. Some parts were just really boring and slow of me trying to figure some things out. But like I say in every video, this is just a live of me going through this, learning with you as we both move along with it. I just know sometimes it's easier to, have somebody to study with. So that is what I'm here for. So I'm not going to have the answers to everything, and I'm not going to pretend I know everything. But I hope, I hope we learn together. That's my hope with all these live videos. All right, so we left off here on 3.13 lab. So it wants us to write a program that reads integers, user num, and div num, so probably a division number, as input, and outputs user num divided by div num 3 times using for division. Okay, so let's start with this. Write a program that reads integers. So we'll start with user num and then div num. So we're going to take that as an input. So integer input. Okay. Oops. Come on. Input. Thank you. Well, sorry, I guess they're going to watch me struggle until my brain catches up. All right, so we have the user input for both a user number and a division number. So as we can see from the example here, a user number, and then that number being divided by whatever number they say here, right? So, and then it wants us to output user number divided by the div number, the division number, 3 times. So print, so it wants us to print the user number divided by the division number 3 times, right? So I'm just setting up the structure here. So the user number by div number 3 times. So it sounds like it's wanting me to take this number and divide it by 2, which equals 1,000, and then take 1,000 and divide it by 2, which is 500, and then take 500 divided by 2, which is 250. So that means I'll need the first result. We'll just do result 1. We'll need a second result. Result 2. And then we need a third result. So it wants us to say, okay, the first result is going to be user num floor division by the div number, right? And then for the second result, it wants us to do the result from the first one divided by the div number again. And then for the third result, we'll take result 2 for division that with div num. And that should actually do it. So we want to take so it's showing the output of result 1, showing the output of result 2, and showing the output of result 3. So we should be able to say result 1, result 2, and result 3, right? I'm just going to run it to see what it looks like. So we'll take that example and say 2,000 to 1,550, or 5, 4, 8, that, and then let's say 32, 175, 0. I don't think it didn't say anything about using, okay, so floor division. So we don't need to do like, decimal places because the floor division is actually removing that decimal places. So, all right, well, let's submit for grading and see if I am correct. Okay, 10 out of 10. That would be cool if it actually showed me what it expected the code to look like, you know, because I'm sure there's a more advanced way to do this, to where maybe I'm not using as many lines, but for the sake of learning, this is how I do it. So as long as the output is correct, that's okay. We'll learn more. Expression for calories burned during workout. The following equation estimates the average calories burned for a person when exercising, which is based on a scientific journal article. So calories equals age times 0.2757 plus weight times 0.0329 plus heart rate, okay, divided by 8.368. Write a program using excuse me, I'm so sorry. Write a program using inputs age, years, weight, pounds, heart rate, beats per minute, and time, minutes. So it'd be like age, weight in pounds, 148 for the heart rate, and time, minutes. So 60 minutes, respectively. Output the average calories burned for a person. Calories burned for a person. So it's taking 49 for the age and timesing it by this number, and then taking the weight and timesing it by this, and then it's dividing by 8.368, right? And that's how this is coming out. That's the way I'm seeing it in my brain. We will find out, but let's see, output each floating calorie point. Okay, so this is how the output's going to be. Calories, and it wants us to have 2 decimal places or 2 decimal digits after the decimal. So 2 digits after the decimal, that's what this is doing here. And then calories. Okay, so, and here's the formula right here. So let's say we need the age. I wonder if I could actually take this and just modify this to be times. We'll modify it and make it make sense to see if it actually does it. So we need the age, we need the weight, and we need the heart rate. Yeah. Heart. I don't like the caps for some reason, so I'm gonna actually adjust the way the variables are here, because I don't like the capitalization for some reason with the variables. I don't know, it just looks like it shouldn't be, you know? So, and then I'll adjust this, I'll adjust this, and I'll adjust this. So that way it matches my created variables. So the heart rate and time spent exercising. So time, so I'll lowercase this as well. We want these to be inputs. So it looks like it's using whole numbers or integers instead of like floats. So I think that's what I'll do. But yeah, I think that's what I'll do anyway, because I don't know when I click submit, I don't know if it's going to run a test as a float, because with age, that'll be an integer, right? But weight could be a float. We'll make it a float. We'll see what happens. Integer input, okay? The weight can be a float, so I'm going to do float input. And then heart rate. I think the heart rate could be, can the heart rate be a float? Like, can it be 148.2 or something like that? I'm going to do it as a float. I feel like it can be. Input. And then the time. So in minutes. So we'll do int input. Okay. So then I'm going to lowercase this here. So we will say, and then let's okay, so print we want to print out calories, and then calories. Just like that. Calories. So let's see if we need to change anything here. So this one, we don't need that. So we're going to do, so this with the parentheses, it'll multiply this first, this second, and this third. Oh, actually, I think that one here, is that for this one? Yeah, that's that ending one. So it'll do everything in here first, times time divided by 8.368, and it wants 2 decimal places. Let's not forget that. So let's test it with these numbers. Oops. Invalid character dash on line in this one here. So where's the, so it looks like it's actually not times, it's subtraction. Let's try again. I removed it. Well, I mean, I redid it and it turned green. So let's see if it did better. So 49, 155, 148, 60. Calories, 736.21 calories. Perfect. So it looks exactly the same. It looks the same to me. So let's see what it gives us. Okay. Given three floating point numbers, x, y, and z, output x to the power of z x to the power of y to the power of z, the absolute value of x minus y, and the square root of x. Output each floating point value with 2 digits after the decimal point, which can be achieved as follows. Interesting. Okay. Let's see. So looks like it already adds import math for us. So given three floating point numbers, x, y, and z, output x to the power of z, x to the power of y, x to the power of y to the power of z, x to the power of y to the power of z, the absolute value. So I'm breaking it down into pieces so that it's easier to understand and read. The absolute value of x minus y, and the square root of x to the power of z. One second here, sorry. Okay. All right. So given three floating point numbers. So let's start with that. So that is x, y, z. Okay. So we'll start with this. Okay. Given three floating point numbers, x, y, and z. Okay. Let's check them off as we go. Output x to the power of z. So this would be, so output x, output x to the power of z. I wonder if it'll actually output it like that. I'm going to run it to find out. So yeah, so it'll say 172 for, okay, so, and then it wants us to do 2 decimals. So let's do that again. Okay. 5.0, 1.5, 3.2. So 172.47, okay? And then it wants us to do print so we did x to the power of z, okay? And then now it wants us to do x to the power of, so x to the power, x to the power, to the power, x to the power of, and it seems like it wants us to do y to the power of z, right? Like that. So x to the power of y to the power of z. So let's test that. So 5.0, 1.5, 3.2. So that's 172.47, 361.66. Why didn't this work? This is supposed to, maybe I can't do it on an F string, that's why. Why does that work though? Is it because it's an F string? Let me see. I think that I'm just checking to see if that's how you write it. Maybe I did it wrong. Yeah, it's because I put in an F string, that's why. So oh, because I got to do it outside of the F string. That's why. So I got to do it that way. That's what it was. Okay, so in case you don't know what this means, it means that it is going to put the print, the print that comes after this print is going to go on the same line as this print. So here, now that I have it correct, I'll show you. Oh, what? Ah, come on, there you go. Okay, so 5.0, 1.5, 3.2. Say it puts it on the same line. So 172.47, 361.26, perfect. So that was x to the power of y to the power of z. So check. So now, now I want to print so print, now we want to do the absolute value of x minus y. So if you don't remember, when the absolute value, if I had, oh, I know I took a screenshot. I can't show you because I think I'm just sharing the page. Oh, I'm not even sharing this. Oh my God. If you've been with me for 30 minutes and just realized that, and I just realized that you can't even see what I'm doing, let me know if you stuck with me for 30 minutes and I'll send you a copy. Okay, there we go. So to recap, if you heard me talking, what I did was the instructions up here, I put them as comments down here because I wanted to break it up into pieces, smaller bite-sized pieces, so it wasn't so confusing. So what I did first was I took in the inputs of the variables, and then I went to the first part here, output x to the power of z. So I output, see if this was live, you could have told me I wasn't sharing, but it's not, so you have to wait 30 minutes or fast forward. So I did x to the power of z. I want 2 digits after the decimal, and I'm going to keep each printout that comes after these printouts on the same line like it shows here. That's what these end equals quotes mean. Okay, but you have to put this outside of your parentheses or your quotes from this F string here. It has to be outside of the F string. So outside of the F string, comma, end. And then I did the second part, which was x to the power of y to the power of z, which is right here, x to the power of, and then y to the power of z. Same thing, 2 digits after the decimal. So now I'm on the absolute value of x minus y. So what I was saying, I was going to show you a screenshot of a reminder of what the math was for, or what the method or function was for finding absolute value. Well, to find it, we have to use fabs. So it says the absolute value, so fabs, right? Fabs, the absolute value of x minus y, okay? So, and then so let's see if it does it this way. So we'll do the same thing, 5.0, 1.5, 3.2. Okay, so fabs is not defined. Did you mean ABS? Do I need to use ABS? Why can't I use fabs? So let's do ABS and see if that does it. Because I know I feel like there's a time that you would use ABS and then the time you would use FABS, like fabs. But let's try this, 5.0, 1.5, 3, 3.2. Okay, perfect. So yeah, so within, it looks like within an F string or using the curly braces like this, I'll have to use ABS. But let's say if I were, doing, if I was like, okay, result equals, then I would say fabs, x plus 4 or something like that, right? I believe, because it's using import math. Actually, I am curious about that. Because I am curious why I can use it in one scenario and not use it in another scenario. Ah, I just realized why. So let's see here. So ABS is actually a built-in math method, where FABS is the mathematical. So as you can see here, we're importing math. So that means I had to do math.f like that, FABS, in order to use it. Whereas ABS, it looks like it's a built-in method. So I'm going to say run again just to test what I'm telling you. So I'm not, yeah, that's what it is, because I didn't use math dot, but I can use ABS because it's built in. But I do want to use FABS only because that's what it taught us to do. So excuse me. Okay, so that 3.50, okay. So it's a good thing I caught that, because it wants 2.2f, 2 digits, and that's how we do that. So then after that, we will do the square root of, so let's print in an F string. So the square root of, so we want to do math.sqrt for square root of x to the power of z. Don't forget to put this in curly braces. Oh, and then don't forget to do your 2 digits at the end. And I don't think I need to, since it's the last print, I don't think I need to add n to add it to the same line, but we'll see. So math square root of x to the power of z. So let's double check now. So 5.0, 1.5, 3.2, and that output 172.47, same. 361.6, same. 3.50, same. 13.13, same. And I was right, because it's the last print of the line of the thing. I don't need to put end at the end of it unless I was going to do another print that I wanted. So it looks like we met the whole thing. So let's go ahead and submit it. Perfect, 10 out of 10. Awesome. Man. All right. I just want to kind of see where I'm at. Okay, so this is the last one, then the key takeaways. So, and then we'll move on to, oh shit, what did I do? Oh, come on, don't make me lose my spot. Oh, good. I just, let's see here. All right, and then we'll move on to types. And then branching. I am curious about branching though. Oh, okay, the FLs. So I'm excited for the ifs, the loops, like whiles, and I'm mainly excited about these, but I'm excited about these three, but I'm mainly excited about these two. And the reason I'm excited about these two is because these are the ones that, like, I feel with any program language is like the bread and butter of programming, because it's reusable. You can get it to do a lot of different things, And same thing with the functions. You can create functions that are reusable, across different, projects, or reusable on any, code you're using, things like that. I don't know if it'll get that in depth or not, but because these are, this is introduction to programming, but it's really cool. I mean, obviously I still have to learn it and grow in it, and exploring it to, get past the intermediate, level, or beginning level, but I'm just excited to start learning it. So, all right, musical notes. Let's get back to it. On a piano, a key has a frequency, say F0. Each higher key, black or white, has a frequency of F0 times Rn. So F0 times R to the power of n, where n is the distance, number of keys from that key, and R is 2 to the power of 1 divided by 12. Given an initial key frequency, output that frequency and the next 3 higher key frequencies. Output each floating point value with 2 digits after the decimal point, then the units, hertz, then a new line using the following statement. Right, so your value by 2 decimal, and then 2 digits at the end, hertz. So if the input is 440, which is the A key near the middle of a piano keyboard, the output is 440. To compute the next 3 higher frequencies, use one statement to compute R equals 2 to the power of 1 divided by 12 using the POW function. Oh, the POW function instead of asterisks. Remember to import the math module, then use that R in subsequent statements that use the formula Fn equals F0 times Rn, with n being 1, 2, and finally 3. Okay, I'm already a little lost, but I'm going to do the same thing we did last time. First, I'm going to import math, and then how can I break this down? Okay, on a piano, a key has a frequency, say F0. Each higher key, black or white, has a frequency of F0 times Rn, where n is the distance from that key, and R is 2 to the power of 1 divided by 12. So given the initial key frequency, output that frequency and the next 3 higher key frequencies. Output each floating point value. Okay, so I'm trying to figure out how the math is being done here. So this is to compute the next 3 higher keys. So we'll do that after we figure out what to do up here. So So let me just kind of look at this for a second here. So I'm trying to figure out the math first. So 440. Says it's saying 440 times times 2 to the power of 1 divided by 12. Like that. So 466.16. Okay, but it wants us to do math.power. Let's see if it's the same. No. So That's fine. Okay, I need to do 2 times power, 2 times to the power of 1 over 12, right? 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 Oh, that's why. So you have to do the base and the exponent. So that means you would have to do like that, right? But that means I would need to take this out then. That doesn't make sense. So 1 divided by 2 is 0. So that's not right, is it? The other way around, maybe. Two to the power of 1 divided by 2, like that. There we go. Okay. So you got to do 2 to the power of 1 divided by 2. So 622, or 4. Well, no, that's not right either, because that's 622.25. Oh, that's so confusing. If I did 2 to the power of 1 divided by 2, that would be easier. Yeah, because it comes up to 440. So, or better yet, like this, right? Six 22.25. That's not right either. Times, if I did this, still 622.25. Oh, duh, fucking idiot. Okay, let's try this again. I just realized what I was doing. So it would be times math.pow 2 to the power of 1 divided by 12. That's what I was doing wrong. There we go. Okay. 46616. That's right. Okay, so math.power 2 to the 1.5, or 1 divided by 12. So let's see. Okay, so now I've figured out the math. So let's do key frequency input. Okay. So this would change to key frequency. Give the initial key frequency, I'll put that frequency and the next 3 higher key frequency. I'll put each floating point. Okay, so. And then technically it wants us to do F, so let's say this 2F. Yeah, okay. So to compute the next 3 higher frequencies, use one statement to compute R equals 2 to the power 1 divided by 12 using the power function. Remember to import that module. Then use that R on subsequent statements that use the formula. And then equals F0 times with n being 1, 2, and prime 3. I'm not sure what that means, so let's use. So it's going to print out. So the first printout, the first one is the input or the key frequency. Okay. R equals 2. Okay, using the power function. Remember, so then use R, then use that R, and so it's going to be just from this. So this is saying print so is it saying print F key frequency times math dot 2 and then 2 and then by 12. Makes sense. For 9388. Yeah, that's what it's saying. Okay. Okay. And the last one is will be key frequency times math pow Okay, so 2, and then 3 divided by 12. Okay. So that should be all 4. So for 40, 4, 6, 6, 16, 388, 523, 25. Perfect. So that outputs exactly how we want it. Once we start using the loops, I know that there's a way to loop this and make it like to use this and use this and use this to output it instead of doing each one individually. Key takeaways. An objective in Python is any value created by an interpreter at runtime. It can be assigned to a variable, example, mylist, but even a literal value like 1, 2, 4 is considered an object. An expression is any piece of code that can be evaluated, ranging from a single variable reference to a complete operation like x is less than 3 plus I times 4. Conditional expression used in if, elif, and while statements. Evaluate to either true or false. Effectively asking questions. Execute. Did we do if statements? I don't think we do if statements yet. Oh, well, I guess it touched on it probably. But then here in branching, we'll start doing that if else branches. Yeah. And then the whiles will be right here in the loops. Cool. All right. So on to number 4. But I'm just going to take a quick minute. All right, so this is where I actually need to end because my kids are almost home from school and it's going to start getting loud. So I am going to continue this tomorrow and get that done. And then we'll move on to finishing types, and then hopefully tomorrow, it doesn't look like, it looks like a shorter one maybe, but types, and then we'll get into branching. So, all right, we'll see you tomorrow.